and we get to talk about, now that we've talked about magnets, how we make them, electrostatics and electric charge, what it is, where it comes from, what rules it follows. Now let's talk about how things can be electrified, so that in the next chapter, which I'll spend in the roughly last hour of class, talking about how we can make electric charges move around. Okay, so something can be electrified by roughly 3 different methods: friction, conduction, or induction. Friction is when you cruised around on the carpet, tall carpet, socks, and scooted your feet on the carpet and then zapped your brother or sister or whatever, right? Electrons can be rubbed off of some materials with very loosely bound electrons onto other materials, even though neither material started off with a charge. Your carpet was uncharged, your socks were uncharged, but you charged up yourself, okay, by scooting around. Friction. This electrifies both materials. The carpet you don't notice because it grounds out, but yourself, you end up grounding to another person and then zapping them. This electrifies both materials, one to a positive charge, the other to a negative charge. Do you have a question? Okay. It seemed like there was something geared up. Okay, anyways, please always feel free to ask the questions if you have them. All right. Friction can cause sudden discharges of electricity, sparks, or if it's a cloud to the ground, it's a lightning bolt, right? And was a constant problem with old X-ray film as it moved across countertops, moved against other pieces of film, in and out of cassettes or bins. This discharge could cause static electricity artifacts and called tree static marks, and they look like a little tree almost. And you can see, like on this chest X-ray, it completely ruins the radiograph. You have to repeat the radiograph, and the patient might be gone now, right? They could be, maybe they're still there, but they're not in position anymore, right? You can't just go reshoot the X-ray. You got to go load another piece of film up. It's minutes later now. Redo the X-ray. All has to be done again. So this made a problem for film. We don't have this type of issue any longer with digital. How do you prevent static electric discharge? Well, you can insulate something, okay? Dielectrics, also called insulators, are materials including rubber, plastic, or oil placed around wires. That's why all the wires are rubber coated. You can ground something, grounding structures to the literal ground with a wire or rod, grounding your electric devices to a grounded plug outlet, right? That's why our plugs have 3 prongs on them, and a good chunk of the electric devices you use have 3 prongs, with the round prong on the bottom being the grounding wire. Humidity. Water molecules are bipolar, positive on one side, negative on the other. They tend to attach to charged surfaces, neutralizing any electric charge built up. So in humid environments, it's harder to build up static electric charge. Keep humidity above 40% if you don't want static discharge. Okay. Let's talk next about, so that's friction. Friction causes static electric charge. How else do we build up electric charge? Conduction is one of these other ways. Occurs when and this term we're going to need to get used to a lot, occurs when a potential difference exists between 2 objects that touch each other, okay? So you cruised around on the carpet, right? Built up some friction electric charge on your body, right? It's on the surface of your body, as we learned, and then you got near enough to your brother or sister or cousin or whatever, right? And then what happened? You zapped them, right? There was a difference in charge between them and you, okay? We call that a potential difference, right? There was the potential for electricity to discharge from, let's say, you to them, okay? There's a difference in charge. They were neutrally charged because they were just minding their own business, right? And you had built up a charge, you were scooting around the house, right? And you come up to them and you got close enough, maybe you even touched them, and you zapped them, okay? This occurs when a potential difference, a difference in charge exists between 2 objects that touch each other, or at least come close enough. The you zapping a family member example works because there's air between you and them, and the charge can travel through the air molecules. So in effect, we're in contact, even though there's a tiny little gap between you. Any difference in charge is also a difference in potential energy. So, and the more charge difference there is, the bigger the potential difference that there is. This is why in X-ray we call the kVp setting kilovoltage potential. Sometimes this is the potential energy. This is the amount of possible energy that you have built up. Right? You zap your family member better when you build up a bigger charge. Right? There's a bigger potential energy, bigger potential difference. Any potential difference generates a force that can cause electrons to move. Excess electrons will always flow towards those surfaces that are relatively more positive or less negative is the same thing. So you have a bunch of electrons built up on you, your family member doesn't, and so the electrons are going to go toward them to equalize the charge between you two. And notice if you've ever done it, it stops very quickly, right? You zap them and then it's over, right? Those charges have now equalized. There's no more potential difference after the electrons jump from you to them.
So does that mean that you can't shock them again?
You can't shock them again unless you go scoot around on the carpet some more and build up some more charge, right? You zapped them once, all that charge left you, right? And you build it up again, and then you can go zap them. Yeah. Now, they haven't built up enough charge to now zap you back, right? It sort of dissipates along the surface of their body, goes right into the ground, and then it's done. Okay. And notice if you've ever done this that you can't like build up some charge and then sit there for hours before someone comes. You kind of have to zoom around and then quickly zap somebody, right? Because it'll sort of dissipate to the ground and back into the carpet, and the charge is gone. But yes, you can't do it again, right? The charge goes away.
If you have two people creating a charge though, and they try to zap each other, do they just cancel each other out?
It would if they built up the same amount of charge, yeah. But likely what'll happen is one of the two will build up a little bigger of a charge, and then it'll just be like a smaller zap. But yeah, absolutely. It's a good one. Yes, if you're both trying to play around, right, and it should equal out. Yeah. Good. We call this force this otherwise potential difference. The force created by this potential difference is called the electromotive force. It's the ability to move electrons, right? And that's what's happening when you zap somebody. You're moving electrons from you to them. Or if you've ever been electrocuted, right? Anybody? Show of hands. I've been electrocuted plenty of times, right? If you've been electrocuted, you know what this feels like when it's a larger charge, right? You get zapped by your little family member or whatever, it's usually no big deal. But if you get, zapped by the 110-volt outlet or your 12-volt car battery, right, it's a bigger deal. Or if you ever touch a 9-volt battery to your tongue, right, that is a potential difference. It's running through your tongue or running through your body, or people that get, electrocuted by lightning, right? Those electrons are moving through them, and there's an amount of force associated with that discharge of electrons. We call that the electromotive force. It's the force that can move electrons. The unit that we use for this force is called the volt. More volts equals bigger potential difference equals more ability to push electrons around, okay? So high voltage means we can push more electrons more quickly, okay? So you cruise around on the carpet, you build up a little bit of potential difference, you build up a little bit of voltage, okay? Cruise around for longer, or have something that can, better socks or better carpet, and you can build up a higher potential difference and get a bigger zap from it, okay? This is the electromotive force, the unit is the volt. We get our plugs in our wall give us 110 volts of electromotive force. Your dryer, if it's an electric dryer, gives you 220 volts of electromotive force. Your car's battery runs on 12 volts, or your car, which with its battery runs on 12 volts of electromotive force, and so on. In our X-ray machines, need between 50 and 120,000 volts of electromotive force to produce X-rays. The volt is the unit that pushes the electrons around in the electric circuits. So X-rays, we need a lot of voltage. The power lines that run to your homes that put 110 volts at your wall, they have something like 15 to 20,000 volts of electromotive force, right? That's why you don't go grab onto those power lines, right? It's not going to be like just touching the wall outlet. You will get absolutely destroyed by the amount of electricity moving through those.
Out somewhere else, either your foot or your hand.
Oh yeah, it grounds, right?
Like
So
it comes out your foot or something.
have you guys ever seen animals just chilling on the wires, right? Birds like to gather on wires. Yeah, those wires are not insulated up there, but a bird can just sit on the wire, right? But if a bird or squirrel ever sat on one wire and touched a nearby wire, not going to go good for them. It's going to travel through their body from one spot to the next. If a person were ever to touch that wire and also make contact with the ground wire or the ground itself, as you're correctly saying, the electricity will travel through them from where they're touching it all the way down to the ground and travel through. Oh, it'll come out their side of their body or whatever. Yeah, path of least resistance, right? Yeah, but like a squirrel can just cruise along the wire and not get zapped because it's not grounding itself. It's not, the electricity is traveling through the animal, but not it's not being grounded. Yeah. So so next time you look up at the wires, notice that the birds are doing just fine, squirrels are doing just fine cruising along them. But as soon as they touch between two wires or can make a connection to the ground, or have the ability to make or if it's like especially humid or something like that, then it can go very bad for them. Okay. Sorry, especially dry, not humid, the opposite of humid. Okay, good. So that's the electromotive force. We talked about conduction. Two objects touch that are one's electrified. The electricity will equalize between the two. The last one is electrification by induction. Inducing a charge in another object nearby without touching it. So a neutral object will become electrically polarized, stronger electric charge on one end than a difference in electric charge from one end to the other, when a charged object is brought nearby. So this example here is a charged rod or wire with a negative charge is brought near a neutral wire or rod, and the neutral wire becomes more positive towards the negative, nearest to the negative rod, and more negative furthest away. It becomes electrically polarized. It has stronger positive charge on one side, stronger negative charge on the other. This is a way of inducing static charge. So that's induction. Okay. I think that's all I want to say for chapter 6. I want to move on. I want to talk about